Hello friends, Satyendra here, and in this video, let's design hook spring and make it flexible in Creo Parametric. So when we design this spring, we'll try to control the spring length using this dimension. And once you make this spring flexible, you can easily assemble this spring into multiple locations in the same assembly. So if you see this assembly, I have assembled the same spring, hook spring, 2 times here, and based on this assembly gap, it automatically flags and adjusts the length. So this is today's topic. So let's get started. Now you're watching my CAD videos from long time. So if in case you're looking for online training classes one-to-one for Creo Parametric anywhere in the world, then share your contact details to my email ID, which is cadxclasses@gmail.com. You can even share your contact number to get a call, and I'll share all the details related to this training. Thank you. Now let's go back to the hook spring. Now let's create this spring one more time and understand the whole process. And for that, first you go to New, Part, take the proper name and say OK. Now I'll start this spring with spring length, and for that I'll go to the sketch, onto the front datum plane, sketch, normal. Switch off all the datums. Now here first I'll place a sketch center line somewhere here, and then I will draw a circle here. Now this dia is dia 35. I will draw one more sketch center line. I'll go to delete segment. I'll trim this portion. Now once this is done, I'll go to offset. I'll select this segment, opposite direction, minus 2.5. One more time, select this, minus 2.5 and say OK. I'll just add few dimensions. One dimension from here till here, this will be 5. Another dimension from here till here, this will be 2.5. Once this is done, I'll select this segment, make it construction, and this segment, make it construction. Once this is done, select all 3 segments, go for mirror, and then mirror with this center line. Now we need to apply this dimension. So for this, first we place datum center point somewhere here and somewhere here. Now the dimension from here till here, this is 100. So when you place a datum center point inside the sketch, you can use it to assemble the spring. So this is that datum point. Now once this is done, I'll create this helical profile. So go to sweep, helical sweep, go for define, select the right datum plane, say sketch, normal. Now here, one more time, sketch center line, just like this, draw the helical profile, like this, select this point as start point. Now this length is nothing but the body length, which is 35. So make it 35. Then you place a datum center line somewhere here. Now this dimension, so this dimension is dia 30, so make it 30. This is this center to this center gap. Now say OK. Now you go for sketch and draw the section. So draw a circle with dia 5 and say OK. Now the pitch, so pitch will be equal to the section dia, which is 5. Now change it to surface, and then you select this option, create helical trajectory curve. Select it and say OK. Ctrl D. Now once this is done, go for remove. Select this surface, hold the Ctrl key and select this. Go for leave open and say OK. Now once this is done, next thing is draw the sketch onto the top plane. Sketch, normal. Now go for reference. Select this reference. Now go for center arc. Select this center. Draw the arc from here till here. Just like this. Say OK. One sketch is done. Now the next sketch. So once again go to sketch. Switch on the datum plane. Select this plane. Say sketch, normal. Now here you go for reference. Select this as a reference and this as a reference. Normal. Now draw the line starting from here like this and like this. Now the dimension, so from here till here, this take it 95 degree. Then add a fillet somewhere here. Now go for offset. Select this curve, opposite direction. So make it minus 2.5 and say OK. Now the dimension. So from here till here, this is 2.5 and this dimension, this is radius 5. Go for horizontal, select this point to this point. Go for vertical, select this point to this point. Now select this curve, make it construction. Select this curve, make it construction. So this is done. Say OK. Now you have two sketches. One is this one, another one is this one. Now using these two sketches, I'll create a 3D curve. So just select this sketch and this sketch and go for intersect. It will create a 3D curve like this. Now once this is done, go for datum, curve, curve through points. Select this point, hold the Ctrl key and select this point. Right click, make it tangent with this curve, flip the direction. Right click, make it tangent. This is correct. Right click, make it tangent, select this curve. This direction is correct, so leave it as it is and say OK. Now the same thing you need to do this side. So one more time, go to sketch, select the top datum plane, sketch, normal. Now first you go to reference, select this reference. Then go for center arc from this center till here. Draw this side. Just like this. Say OK. This is done. Now one more sketch. So go to sketch. Again right datum plane. Sketch, normal. Go for reference. First you select this reference and then you select this reference. Close it, normal. Now draw the line starting from here, this side and this side. Now the dimension, so from here till here, this is 95 degree. Add the fillet from here till here. Now one more time, go to offset, select this segment, minus 2.5, say OK. Now go to vertical, make this point vertical with this, go to horizontal, make this point horizontal with this. Now the dimension, so this gap is 2.5 and this radius is radius 5. Now once this is done, select this curve, make it construction, and select this curve, make it construction. Say OK. So one more time, you have this curve and this curve, both you select it like this, go for intersect. So this is done. Now again go to datum, datum curve, curve through point, select this point, hold the control key and select this point. Now right click, make it tangent and select this curve, flip the direction, right click, make it tangent, select this curve, flip the direction, say OK. So till here we have created all the curves. Now go for sweep, select this curve, hold the shift key, select this, 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 then you select this, this and this. Go for sketch, draw the circle somewhere here. This die is die 5, say OK. Say OK. So you got the spring. Now we'll make this spring flexible. So when you make this spring flexible, practically this length, which is the spring length, this length will change. So let's change this length and see what happens. So let's make this 100 as 120. The spring doesn't flex. So practically when you change this length, this should not change. This gap and this gap remain as it is. This length, which is the body length, this length should change. So here it is not happening. So to make it happen, we need to write a relation here. So before we write the relation, I'll just rename some of the dimensions. So this dimension, this is 100. Now I'll just rename this dimension. If I select this dimension name is D3. I will make it as spring length. Now if you select this dimension, it will highlight as spring length. Then the next dimension, which is somewhere here, this dimension, this is the body length. Now one more dimension, which is inside this pitch. I'll select it and I'll change the name as pitch. So to keep this area and this area constant and to vary the body length, we need to write a relation. So go to relations and the relation will be body length equals spring length minus 65. So here the body length is 35 and the spring length is 100. So 100 minus 35 is 65. So when you calculate this relation, body length equals 100 minus 65, which is nothing but 35. So this is one relation. Just verify it and say OK and say OK. So the relation is done. Now let's change the spring length one more time. So make it 120. Now when you change the spring length, the spring fails. Now one more thing you can notice here is when you increase the spring length, it increases number of coils. So practically when the spring flags, these number of coils must be constant. It should vary the pitch of this coil to keep this number of coils constant. So to keep the number of coils constant and to make the pitch variable, we need to write one more relation. So go to relations one more time and here you write one more relation, and the relation will be pitch equals body length divided by 7. So body length is 35 here, divided by 7 is 5. So when body length is 35, pitch will be 5. If the body length increases, pitch will increase. Just verify this relation, say OK and say OK. Now Control G to regenerate. So now it is working. Now let's increase the spring length, make it 150. Control G, it is still working. Make it 100. So now the spring acts like a flexible spring. Now once this is done, I will assemble this spring inside the assembly and check the flexibility. So for that, go for new, go for assembly, take a name, say OK. Here first I will assemble this part. I will make it default, say OK. So I have assembled this part. Now here I will assemble the hook spring into two different locations with two different length. So let's do that. So go for assemble, go for in session. This is the part I have just created. Open it. Now I'll just switch on the datum point. So now I'm going to use these datum points to assemble the spring here and here. So first I will select this point, I will assemble it somewhere here, and then I'll select this point and I will assemble it with this point. Uncheck allow assumption, rotate the spring like this, switch on the datum plane and then new constraint, align this plane with this plane. Say OK. Control D. Now the same spring I am going to assemble in between these 2 points. So one more time assemble, go for in session, select the part. Again I will select this point. I will assemble with this point. Now this point I cannot assemble here, so I'll just say OK. Now first I will make the spring flexible. So select the spring, right click, go to flexible component, make flexible. Now when you make this spring flexible, practically you are making one dimension flexible. So which is that dimension? Just expand it and go for the spring length. This is the dimension. Select this dimension, say enter. Now go for by value, change it to distance. Now distance is from here till here. This is the distance. Currently it is 130. Just say OK and say OK. Now see, the spring became flexible. Now one more constant, switch on the datum plane, align this plane with this plane, and then this point with this point. Say OK. So now you have assembled the same spring 2 times here with a different spring length. Now let's do one more thing. Change this length. Let's make it 150. Control G. Now see, since this spring is flexible, it is flexing as per this gap. This spring is not yet flexible, and that is why it is not flexing. So let's make this spring also flexible. So you can make the spring flexible after assembling it or before assembling it. So if you make it flexible before assembling, then it will flex as per the assembly gap. So again, here also you need to look for that dimension which you are trying to make flexible. So this is that dimension. So enter. Again go with by value, change it to distance, and here also from this to this gap, this is 150 currently. Say OK and say OK. Just say OK. So now both the springs are flexible. Now just increase or decrease this dimension, make it 120, Control G, make it 100, Control G. So now these two springs are flexible. So as per this assembly gap, it will flex, and for this we have added two relations here. One relation to control the body length, which is nothing but this length, and then the second relation is to control the pitch. So as per the body length, number of coils must be constant and the pitch must vary. So when the body length increase, the number of turns must be same, but as per the change of body length, the pitch should vary, and that is controlled by these two relations. Say OK, and your part is done. So this way you can design your spring and control the spring length the way you want. So that's it from this video. So this was the hook spring in Creo Parametric, and I hope this video will be helpful. Now you can like this video if you find this video helpful, and you can subscribe to this channel to support this channel. Thank you.